Alright, so for the problem number 2, we have now written this problem down, and again, I've got a 2 that power that I can deal with first. So I can deal with this power before you do anything else. So it becomes log of x plus the log of 2 to the third equals the log of 2x minus 7. Addition means multiplication. So this becomes the log of x times 2 to the third. Reminder, 2 to the third is 8. I'm going to change to that next. Now, you don't have to write both the green and the black steps. You can just write one of them, it's totally fine. And go straight to the green. But now log equals log, so I can drop the logs. And go 8x equals 2x minus 7. That's an easy one to solve. So 6x equals negative 7. So I get x equals negative 7 over 6. And I got to check it. And if I go to the very first one, it's log of x. So it'll be log of negative 7 over 6, which you can't do. Which means this doesn't work. Which means because that was the only one, there is no solution to this picture, or to this equation. Now, you can always check. You can use your calculator to check it. You are not allowed to use your calculator to solve these. But you can use your calculator. You can graph the left-hand side and graph the right-hand side and tell me where they intersect. There's a way to do it. However, when it says give exact answers, we are not going to let you do that. Now here's example 5. Example 5 is worded differently. Example 5 says, let f of x equal the natural log of x minus 10, or natural log of x plus 10 minus the natural log of x, and g of x equaling the natural log of x plus 3. Find all the values where f and g intersect. If they intersect, that means they're equal to each other, so let's set them equal to each other. So f of x has to equal g of x, or the natural log of x plus 10 minus the natural log of x equals the natural log of x plus 3. Minus means subtraction in our world. X plus 10 over x equals the natural log of x plus 3. They're both natural logs, so I can drop the natural log and just have x plus 10 over x equals x plus 3. I personally am just going to multiply by x. So x plus 10 equals x squared plus 3x. I'm moving everything to one side because I've got an x squared and an x, which means I need to solve. So x squared plus 2x minus 10. This I can factor. Factors of negative 10 that add to be positive 2 are x plus 5. Nope. They're not. 5 and 2. 5 and 2 makes 3. Alright, so if it's not 5 and 2, that did not work nicely. It's totally fine. Oh, excuse me. Alright, so quadratic formula. Because it doesn't factor nicely, the factors are 5 and 2, and that adds to be 3, and 10 and 1, and those don't add to be 2. So, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Yes, you should know the quadratic formula. Negative 2 plus or minus the square root of, this is positive 40, and that's 4, so that's 44 over 2. And I'm going to come over here because I have lost room. 44 does break down into 2, 4, and 11. So it becomes x equals negative 2 plus or minus 2 squared of 11 over 2. Because you have this piece, and this piece have something in common. I can simplify. Divide all those by 2. So it becomes negative 1 plus or minus the square root of 11. There are 2 answers here. There is and x equals negative 1 plus the square root of 11, and then x equals negative 1 minus the square root of 11. Negative 1 plus square root of 11 is not a problem. That's a positive number. But the negative 1 minus the square root of 11 is an issue. So that is a negative number. Straight out negative. It can't happen because you're talking about the natural log of a negative number. There's my answer for that one. So again, it doesn't have to be a nice, pretty answer. If it's on a calculator portion, you could have graphed and found the intersection, and I will show you that momentarily. As you can see, I have plugged in the natural log of x plus 10 minus the natural log of x, and the natural log of x plus 3. I'm going to do a zoom 6 to make sure my window is just the same window that I've been doing. And you know what? Here's my intersection. Notice there's only one. There is a vertical positive right here and a vertical positive right here. That's the only intersection. Second trace, intersect. And I needed to get, notice it says y equals 0. It wasn't anywhere, but I can see it now. And I can see this one now, and I'm going to ask it to guess. And there's my intersection. Now, I'm going to go to the home screen, and I'm going to type in this x. I'm going to type in x. That was the last thing that was written there. So you can see it. It would be negative 1 plus square root of 11. You'll notice that they are the exact same answer. I'm going to give one answer. And there it is. So if I had a graphing calculator and it was on a graphing calculator section, I could allow you to do that. It didn't say that, and it didn't give you that. I did not give you that option. But I want to show you that that is a great way to check your answers. Example 6 says, let h of x equal this and k of x equal this. What are all the x coordinates? The x coordinates of where they intersect. So, log base 3 of 2x minus 3 plus log base 3 of x plus 4 equals log base 3 of 8x plus 2. Plus means multiplication. So log base 3 of 2x minus 3 times x plus 4 equals log base 3 of 8x plus 2. They both have the same log, so I can drop it. And I can go to 2x minus 3 times x plus 4 equals x plus 2. 8x plus 2, sorry. I have to FOIL the left-hand side and move everything over. 2x squared plus 8x minus 3x minus 12 equals 8x plus 2. I'm coming up here for room. This gives you plus 5x. So I'm going to have 2x squared, and then I'm minus 3x, so minus 3x minus 14 equals 0. Why did you say? I'm subtracting 8x. I'm subtracting 2. Now, there's not a GCF, but I am going to do factor by grouping. 2 times negative 14 is negative 28. Factor to negative 28 that add to be negative 3. 7 and 4 work, but I need to be a negative 7. So it's going to be 2x squared minus 7x plus 4x minus 14. Factor by grouping says x minus 7, and then positive 4, and 2x minus 7. And then look, they both have a 2x minus 7. That was a little blank. And then x plus 4. So I have 2x minus 7 equals 0. X equals 7 halves. X plus 4 equals 0. X equals negative 4. Question is, are they both valid? 7 halves is going to be okay. Negative 4. Negative 4 plus 4 is 0, but you can't have 0. You can't take the log of 0, so this is not valid. There is only one x coordinate. It is 7 halves. All right. What if we do log? What if we do it the other way? What if we're doing exponentials? I'm going to show you a couple ways to find them. One is to find a common base, and the other is to solve with logs. So the first thing I'm going to do is I'm going to do common base. A is great. It's got a common base. They're both base 2. So, same bases, ignore the bases, and just set your exponents equal to each other. Here's the joy of exponential form. If it started in exponential form, you don't have to check any of your values. You don't check solutions. Every solution is valid. So, minus 2x, 3x minus 1 equals 7. 1 plus 1. So 3x equals 8. X equals 8/3. Great. The issue of B is that they don't have the same base, but I can transform one of them. I can make 8b 2 to a power. Because, if you remember that 8 is 2 cubed. So 2 cubed to the power of 3x minus 2 equals 2 to the x plus 5. Or 2 cubed is, so this is going to be 2 to the 9x minus 6 equals 2 to the x plus 5. After power, you multiply. Bases are the same, so you can ignore the bases and just write the exponents. So I can solve this. So that's going to be 8x equals 11. So x equals 11 over 8. Which is fabulous. That's too far. Number 9, 9 and 27, neither of those are the same, nor can you make a 9 into a 27, or a 27 into a 9. What I can change is both of them be a base of 3. So 9 is 3 squared to the 2x, and 27 is 3 cubed. So 27 becomes 3 cubed to the x plus 2. Now they have the same bases, and I can do some multiplication. So this becomes 3 to the 4x, and this becomes 3 to the 3x plus 6. Multiplication. Power to the power you're multiplying. Bases are the same. I can set your exponents the same. Well, that was an easy one, so x equals 6. 1/2 and 4 are not the same, but I can rewrite them both to 2 to a power. 1/2 is 2 to the negative 1 power. So I need you to recognize that 1/2 is 2 to the negative 1 power, and 4 is 2 to the second power. Again, always look for what base can I write them both in. What base can I write them both in? 2 to the negative 5 minus negative 5x minus 7, and 2 to the 2x. Okay, they have the same bases. Now I can just ignore the bases and just write the exponents. So negative 7 equals 7x. Divided by 7. So negative 1 equals x. And this is the case where I can have a negative x and negative value. It doesn't matter for me for a negative value for this. You're allowed to have negative values for this. Alright. So now what happens if I want to find inverses? A reminder about inverses. Inverses means you're switching x's and y's. Right? And we're going to talk about an inverses in terms of the general form. Alright? Again, just like we did before, and again, here's the general form for exponentials, and here's the general form for logs. How to move left, right, up and down, so on and so forth. But if I'm finding inverses, again, just like we done before, you are switching x and y's, you are solving. And then you write the correct notation, which means I'm going to write it as f to the negative 1 power. F to the negative 1 of x, that's the inverse function. Or g to the negative 1 of x, and so on and so forth. So the first thing I'm going to do is I'm going to switch, this is y, so I'm going to switch x and y. So it comes 3 times, x equals 3 times 2 to the y plus 4 minus 15. You cannot multiply 3 and 2 and get 6 because 2 is attached to the power. The whole point is to get that, you have to get y by itself. The whole point is to get y by itself, so the first thing I'm going to move is I'm going to move the 15. So I'm moving the 15 to the other side. So x plus 15 equals 3 to the 2 to the y plus 4. Again, get the y plus 4, which means the 2 piece has to be by itself. Someone divide by 3. So I have x plus 15 over 3 equals 2 to the y plus 4. If you want to, you can write this, you can leave the blue, or you can write this as 1/3 x plus 5. That's up to you. But now, because the 2 is by itself, you are now going to put it into log form. So I'm going from an exponential to a log. So log base 2 of 1/3 x plus 5, or x plus 15 over 3, equals y plus 4. My last step is to subtract 4. So I have log base 2 of 1/3 x plus 5 minus 4, parentheses out of here, equals, and this is f to the negative 1 of x. There's my final answer. We're going to go the opposite way for this one. For example 2, we're going to go from log, and our common answer should be an exponential form. But again, I'm going to switch x's and y's to start off with. So x equals negative 3 log base 5 of y minus 4 plus 6. Excuse me. So again, getting the log term by itself. So x minus 6 equals negative 3 log base 5 of y minus 4. Again, getting the log term by itself. So x minus 6 over negative 3 equals log base 5 of y minus 4. You can make this negative 1/3 x plus 2. You'll leave it like this. I'm going to leave it like this because I didn't last time. But now the log is by itself, so I'm going to take it out of excuse me. Take it out of log form, put it in an exponential form. Equals 5 to the x minus 6 over negative 3 equals y minus 4. Add 0 both sides. So it becomes 5 to the x minus 6 over negative 3 plus 4 equals, and this was y, but I'm going to make this g to the negative 1 of x, because that's the proper notation. By the way, if you wanted to, you could write this as 5 to the negative 1/3 x plus 2 plus 4 equals g to the negative 1 of x. That's the other way to write this. Alright. So, example 3 says let h equal 3 to the x plus 1 minus 2. Let k of x equal the inverse of x. And it says for what values of x does k of x equal 1? So k of x is the inverse of this, so let's find the inverse of this. Yeah, let's go that way. So x equals 3 to the y plus 1 minus 2. So this is the inverse. Here's the question. Ladies and gentlemen, this says that y has to equal 1. Now I can solve for y, totally fine with doing that, but I could also say, for what value of x does k of x equal 1? This is the value. This would be k of x solved for y. The reality is, I don't need to solve for y, I'm just asking for what the value is when y equals 1. I know where y is, I can plug in 1. So I'm going to shortchange and say that I can't. 3 to the 1 plus 1 minus 2 equals 3 squared minus 2, or 9 minus 2, which equals 7. And x equals 7. When y is 1, x is 7. Now, if you wanted to solve this for y, you totally could. I'll show you how you're going to get the same answer. So x plus 2 equals 3 to the y plus 1. So log base 3 of x plus 2 equals y. We know that this has to equal 1. Now if I put this in log form, it becomes, or an exponential form, because that's how I'm going to solve it. 3 to the first equals x plus 2. So when you subtract 2, x equals 1. Two different ways to do it, got the exact same answer. They both started off the same way. What do you recognize? Alright. If we are solving inequalities, they again make the same way, but just like we've done before for solving inequalities, you have to do a sign chart. Right? We have to do a sign chart. So, I'm going to start off here at the back, and it's got a subtraction, so I'm automatically going to write it as division. And I'm going to say that this has to be greater than 0. Right? So that means I want to know where this thing is equal to 0. When it's greater than 0, I'm going to actually solve the equation. Equal to 0. Because then I know where my values are on my sign chart. So I can't do it by logs, but I can do it by taking it out of log form. This is base 10 because it doesn't say any other base. So it becomes 10 to the 0 equals x squared plus minus 4x plus 7 over x plus 3. 10 to the 0 is 1. So 1 equals x squared minus 4x plus 7 over x plus 3. I'm going to multiply by my denominator. Get rid of it being a denominator. So it becomes x plus 3 equals x squared minus 4x plus 7. I'm moving everything to one side. So 0 equals x squared minus 5x minus, or plus 4. We are subtracting x. Subtracting 3. Hey, that factors. Isn't that nice? It factors into negative 4 and negative 1. And so I have x equals 4 and 1. That's my sign chart. So, there's a number that's less than negative 1, or less than 1, we can do 0. I stick in a 0 here. This is going to give you 7 on top and 0 on the bottom. I'm sticking it in right here, because that's just easier. The blue stuff. Log of 7 over 3. As long as the log is bigger than 1, it is, as long as the number is bigger than 1 inside the log, it's positive. So that means it's positive. Let's choose, oh, I don't know, 2. If I do 2, so 2 squared is 4, that's 11, and minus 8, and this is going to be 5, and that is going to be negative, because it's a number that's smaller than 11 minus 8 is 4, 4 over 5 is smaller than 1, so this is going to be negative. So that's what I have to think. Is the number bigger than 1 or smaller? The log of the number, is it bigger or smaller than 1? Smaller than 1 means it's going to be negative. Bigger than 1 is going to be positive. And I will guarantee that 25 minus 20 is 5. 5 plus 12 over 8. That is bigger than 1. So that is positive. I wanted to know where it was positive. So it's from negative infinity to 1. And then, ooh, we got to write this on. And then 4 to infinity. But a reality check is, ladies and gentlemen, you can't put anything less than negative 3 in here because there are restrictions. Because this can't be negative. So negative 3 is my restriction. So it's not actually negative infinity to negative 1. It is negative 3 to 1. Because there's a horizontal asymptote at negative, or vertical asymptote at negative 3. So negative 3 to 1 and then 4 to infinity. Example 5, one's less than another. So the natural log of x squared plus x minus 5 is less than the natural log of x plus 4. I'm actually going to move them both to one side. We'll talk about why in just a second. Because we're talking about these, we have to talk about it being less than 0. Oops, I lied. I jumped ahead, so let me do step. Natural log of x squared plus x minus 5 minus the natural log of x plus 4 is less than 0. Subtraction means division. I need to set it equal to 0 because that's how I'm going to find my zeros. So that means that this is going to become e to the 0, this is natural log, e to the 0 of x squared plus x minus 4 over x plus 4. E to the 0 is 1. So 1 equals x squared plus x minus 5. I changed to 4 for some odd reason. Minus 5 over x plus 4 multiplied both by the denominator. So x plus 4 equals x squared plus x minus 5. Move everything to one side. So 0 equals x squared minus 9. So 0 equals x minus 3 and x plus 3, or x squared equals 9. So x equals plus or minus 3. Those are the values that are going on my sign chart. Negative 3, positive 3. Yeah, so negative 3, by the way, is okay. You can't go any more left than 4 because of this piece right here, the negative 4. So I know, by the way, that there's a stopping point at negative 4 because there's a vertical asymptote at negative 4 at h of x. But let's talk about our numbers. So I'm going to choose 0 just to make my life easier. The natural log of 0 is an issue because it's negative 5/4, so the natural log of 0 doesn't work, so this is undefined in here. Because 0, negative 5 over positive 4 is 0. 5. That's an issue. So that's out. And then let's see. Negative 3.5. Negative 3.5 is fine at the bottom. 9. 3.5 of 9. What is that? Stay in my head. Negative 8.5. Negative 3.5 squared is like. So it's positive over positive with the number bigger on the top, so this is positive. But if I do like 5 squared 25, and that's 30, so this is positive here. Alright, now here's the issue. What I forgot to talk about is we talked about the domain for this piece, right? We said the domain has to be from negative 4 to infinity. We haven't talked about the domain for g of x. So I'm going to go down to the side, and we actually have to talk about the domain for g of x. So when does this thing, I'm going to come down here in this space, and I'm going to talk about x squared plus x minus 5, because that has to be greater than 0. But that doesn't factor. So you actually have to use quadratic formula, which is a pain. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 1 plus or minus, that's 21 over 2. Now I am going to give some decimals here just because in the interest of where they land on the sign chart, it will be easier if we talk about them being on a sign chart in terms of numbers. So I'm going to take a calculator. I don't want to talk about I'm going to grabbing this, and I'm going to do negative 1 plus square root of 21 all over 2. And then I'm going to take this minus this. Now, these two numbers actually are important to me. Can we unmute so we can see them? So I'm going to care about x equals 1.79, 1, 2, and x equals negative 2.79, 1, 2, or 1, 1, 2, 8, 1, 3. Okay, here are 3 decimal places. Now the reason I say that is because now that undefined piece is not the whole thing, right? There's a piece in there now that I have to talk about. So reality is I need to do a different sign chart. I need to do a sign chart that has, we stopped at negative 4, negative 3 was good, this was positive, but we actually have to talk about negative 2.79, 1.79, and then 3. We know that's positive. Now, we already checked 0. 0 was undefined, so this doesn't work. We know that. The questions are the other two pieces valid? That's the question of the day, is are the other two pieces valid? And the answer is yes. And so the question is, where do they land? If you look at the numbers, and this would be a calculator question. I mean, instant time is going to tell you when you plug in a number between these two, yes, negative, and yes, it's negative. Which means the answer to this is where we're negative between negative 3 and negative 1 minus the square root of 21 over 2. And then negative 1 plus the square root of 21 over 2 and 3. Please note I went back to the original because that is the exact answer versus the rounded decimal. I used the rounded decimal, but I did go back to my original to give me the answers for that. The last one, number 6. What are the values for which this is less than or equal to 31? So 1 minus 4 times 2 to the x minus 3 is less than or equal to 31. I'm going to solve this like I've done all the others. I am going to change it to an equal sign just to make it easier. Actually, let's do this way. So I'm going to solve. Minus 1, negative 4, 2, the x minus 3 is less than 30. Oh, negative 31, sorry. Negative 31. I knew something was wrong. Which makes this negative 32. So I'm going to divide by negative 4. FYI, when you divide by a negative sign, your inequality switches, so it becomes 2 to the x minus 3 is less than or equal to 8. Oh, I said it and didn't do it. Is greater than or equal to 8 because we divided by a negative sign. Now 8 is the same thing as 2 to the third power. So I could write this as 2 to the third power. So 2 to the x minus 3 is greater than or equal to 2 to the third. Same basis, you're just dealing with your exponents. So x minus 3 has to be greater than or equal to 3. So x has to be greater than or equal to 6. Ladies and gentlemen, please don't forget to upload your notes to Schoology so that we know that you have done your notes for this unit. Your homework is on your assignment sheet. It is in your packet. You do have an activity to do with your groups or with your partners.